Hello, everyone. Have you ever walked into a library and wondered how did they know exactly where every book is? Thousands, sometimes hundreds of thousands, even millions of books. Yet somehow, a librarian can help you find one specific book in just a few minutes. That isn't magic, it's mathematics. Today, we are going to discover the hidden mathematics behind libraries. We'll see how numbers organize books, how geometry determines shelf space, how probability predicts which books people borrow, and how mathematics help libraries store an incredible amount of knowledge inside one building. By the end of this episode, you will never look at a library the same way again. Let's begin. Before a library can organize books, it first has to organize space. Everything begins with simple geometry. Okay, so let's say this is a floor space. Okay, and then you have shelves. Okay, so each shelf, so this is a shelf, each shelf occupies space. So this is a shelf. Each aisle occupies space. Okay. Reading tables. Let's say we have a reading table here. Okay, that occupies space. Emergency exit, that occupies space. A library isn't just filled with books. It's carefully designed using geometry. So architects calculate width, length, walking distances, visibility, accessibility before the very first bookshelf is installed. Every square foot has a purpose. So let's zoom in into a shelf. Okay, so let's say a shelf is like this. Okay, it's about 36 inch. Okay, and then a book on average, it's about the book thickness is about 1.5 inches. So how many books can fit on this shelf here? 36 divided by 1.5. That's about 24 books. Okay. So now add, let's say you have 6 shelves here and so forth. So 6 shelves, okay, at 24 books per shelf. So it's about 24 times 6. That's about 144 books. Okay. Now, let's say you have 20 bookcases. So it's 144 times 20. That's about 2,880 books. Now, you realize suddenly that one room can already hold nearly 3,000 books without any hiccup. That's mathematics at work. So, why are books uh, numbered instead of titles? Okay, so imagine you have 50,000 books. Will arranging this alphabetically be enough or efficient? Not really. So, math comes to help here. Okay, as you know, libraries have multiple topics and subjects: history, music, medicine, photography, okay, to name a few. So, library solve this to avoid mixing all these various topics by introducing numbers. We'll see numbers like this: 100 or 00, 100, 200, 300, 400, so forth, all the way through 900, sometime 1000. So, depending on how large the library is. So, certainly, books are grouped by subject. Instead of searching randomly, you only need to search one section. Numbers reduce search time dramatically. Mathematics create order from chaos. Let's look into the mathematics of finding one book. Suppose one library has 100,000 books. Okay? You want exactly one book, not all 100,000. Without organization, finding it could take hours. With mathematics, it takes a few minutes. Okay? So you have 100,000 books. Okay? You need one book. Okay? The organization system narrows your search step by step. So what the organization system does, it breaks it down to by subject, author, call number, shelf, position. So instead of searching all 100,000 books, you are really searching only a handful. That's efficient just by simply using the numbering system. So you can categorize this thing. You can say music here, the photography, cuisine, travel, to name a few, um, history, of course, geography, and so forth. So by numbering them, you break it down and narrow the search. Okay. So let's look into the borrowing books as a probability issue. Okay. Not all books are borrowed equally. Some books leave the shelf every week. Others may stay for months, nobody touches them. Library actually study these patterns. Okay. So they will go from, of course, mystery, science, history, children, biography, fiction, of course, or nonfiction. Okay. So by differentiating them, help locate that book faster, much more efficiently than if they were just laying there randomly. So probability will help get that book quick. Now, what does that do? Let's say in the DC Public Library, according to the Washingtonian, in 2025, the most popular book in the library system was The God of the Woods, okay, by Liz Moore. This was one of the most popular books borrowed in DC. Now, let's assume that a library has one copy of this book and then one copy another book that does not go fast or that stay on the shelf for an extended period of time without being taken. So if this book is the one that is the most used or most borrowed, The God of the Woods, what will libraries do? Naturally, they will acquire multiple copies of this book because a lot of people are asking for this book, rather than having one copy of this book and then have multiple copies of a book that does not get requested or checked out, as they call it, more frequently. So the God of the Woods will have definitely more space. So instead of one copy, they'll have multiple copies. What? They'll calculate maybe the book is going every week. So they'll have 7 copies of this book or 10 copies of this book, depending on how really the book is going fast and coming back. So all that is taken into consideration when libraries are designing and actually storing the shelves. Let's come back to the God of the Woods by Lismore. Somebody is going to the Lamond Riggs neighborhood library. Okay, that is in Northeast DC. Okay, and the person goes there and is looking for the God of the Woods and could not find this book. Okay, so what happened is um, the library system itself is in a network. The DC Public Library has about 26 branches through, throughout the city. That includes 25 local ones and the central MLK library on G Street in Northwest DC. So these total of 26 branches have are interconnected. So if one person, if you go to, let's say, as I said, to the Juanita E. Thornton or the Lamont Riggs neighborhood library, you can't find your book, you can go to any of these books, or actually the librarian can help you call or contact the other libraries and see. Let's say you go to Mount Pleasant. Mount Pleasant may have the book, and you can necessarily borrow it from there. Now, if you can't find it at all at any of these 26 libraries, the DC Public Library System has an active reciprocal borrowing agreement with some jurisdiction in Maryland and Virginia. What does that mean? Let's say somebody couldn't find a book that they were looking for in any of the 26 branches, which is not likely, just for the sake of the argument. So what the library system has done was to create a reciprocal borrowing agreement with Montgomery County, PG County, Frederick County, and Charles County in Maryland, the same as in Fairfax County, Arlington County, Loudoun County, and so forth in Virginia. So you can use the same library card in DC and go to these other municipalities' libraries and borrow a book from there. And it is at no additional cost to you. Now, to dig in even further into that thing, while public libraries share physical access, local academic libraries go a step further with deep resource sharing. Colleges and universities locally here in the DC metro area are part of the Washington Research Library Consortium, uh, abbreviated as WRLC, which allows students and faculty at different institutions such as Georgetown, George Washington, and Howard to borrow books, share collection, and request interlibrary loans from partner campuses. So just to make it easy for you to borrow that book. Okay. So let's come back to our libraries. Okay. One specific library. The weight of knowledge. Books are surprisingly heavy. So let's say this is a book. Okay. Okay. This is a book. How much do you think books weigh in on average? On average, here in the US, books weigh about 2 pounds. Okay. So if you have 10,000 books, you multiply that by 2, guess what you get? 20,000, right? That's 20,000 pounds. Okay. That's about 10 tons, guys. Now imagine 10,000 books. That's nearly 100 tons. Bookshelves aren't just furniture, they're engineered to safely support enormous amount of weight. Even the floor underneath must be designed for it. Engineering here meets mathematics. A library math challenge. Let's estimate that your local library has 150 bookcases. Okay. Each bookcase has about 6 shelves. Each shelf has about 24 books. Okay. So what do we have here? 150 multiplied by 6, that's about 900 shelves. Okay. 900 multiplied by 24, that's about 20,600 books. Without counting a single book, we've estimated the size of the collection. That's the power of mathematics. Today, we discovered libraries are much more than buildings filled with books. Geometry determines how buildings is organized. Arithmetic tells us how many books fit on each shelf. Numbering systems organize every subject. Probability helps libraries understand what readers want. Engineering supports thousands of pounds of books, and networks connect libraries across entire regions. The next time you visit a library, remember that behind every shelf, every aisle, every call number, and every book you borrow, there is mathematics quietly making knowledge easier to find. I would like to invite librarians to chime in here to further expand our investigation here and see how they can help us understand more how libraries work. Libraries, chime in. You're welcome to put in a comment. Okay, so if you anybody else, if you enjoyed today's episode, please give it a thumb up, subscribe to the channel, and share this video with someone who loves reading book or someone who thinks mathematics has nothing to do with everyday life. Because as we've seen once again, mathematics is everywhere. Thank you for watching.